Pauline, and you are watching DepEd MP TV. Today, we will discuss the trigonometric ratios of special angles. So be ready with your paper, pencil, and your self-learning module.
In the last lesson, we learned about the 6 trigonometric ratios. In this week's lesson, we will explore the properties of special triangles and aim to describe the relationship of the sides and angles of a 45-45-90 triangle and a 30-60-90 triangle. Second, find the trigonometric ratios of 45-degree, 30-degree, and 60-degree angles. And third, determine the values of expressions involving trigonometric ratios of special angles even without the use of calculator.
But before we move further, let us check how much you already know about our topic by answering the pretest on page 3. Read and understand the questions, then choose the correct answer, and then write the letter that corresponds to your answer on your answer sheet. You will be given 3 seconds to answer each item.
First question. What do you call the mnemonic device to easily remember the primary trigonometric ratios? A. Kaosha-cho, B. Kaso-towa, C. So-ka-towa, or D. Towa-kaosha. Question. What is the value of y with respect to the given acute angle in the figure? A. 9, B. 4 and 5/10, C. 9 the square root of 3, or D. 6. Question. What is the value of x with respect to the given acute angle in the figure? A. 9, B. 4 and 5/10, C. 9 the square root of 3, or D. 6. Fourth question. Which of the following trigonometric equations is incorrect about the figure? A. Cosine of 30 degrees is equal to y over 18. B. Sine of 30 degrees is equal to 18 over x. C. Sine of 60 degrees is equal to y over 18. Or D. Cosine of 60 degrees is equal to x over 18. For items 5 to 10, pause this video then continue answering. Let us check your answers to the 10 items in what I know. Number 1, C. 2, C. 3, A. 4, B. 5, B. 6, C. 7, C. 8, A. 9, B. and 10, B.
How well did you do in the pretest? If your score is 8, 9, or 10, give yourself a tap on the shoulder. If your score is 7 or lower, do not worry because the next activities will help you master this lesson. So shall we start?
Open your module to page 4, What's in? Last quarter, we have learned about the 45-45-90 triangle and the 30-60-90 triangle. Let us first try to recall the relationship of the sides and angles of the 45-45-90 triangle. Consider triangle DEF. Which angle is the right angle? That's right! Angle F is the right angle. Which side lies opposite the right angle? You're right! Line segment DE lies opposite the right angle. Therefore, line segment DE is the hypotenuse or the longest side. What can you notice about the other two sides, line segment DF and line segment EF? You really are observant. Line segment DF and line segment EF are equal in length. The sides are called legs. Now remember that with respect to the legs, the hypotenuse is equal to leg times square root of 2. Next, let us review the properties of a 30-60-90 triangle. Consider triangle ABC. Which angle is the right angle? You got it! Angle C is the right angle. Now, can you identify the hypotenuse? Exactly! Line segment AB is the hypotenuse. Which side is the shorter leg? You said it! Line segment BC is the shorter leg. And of course, the third side, line segment AC, is the longer leg. Recall also that with respect to the shorter leg, the hypotenuse is equal to shorter leg times 2. In other words, the hypotenuse is twice as long as the shorter leg. And the longer leg is shorter leg times square root of 3. Now, with respect to the hypotenuse, the shorter leg is hypotenuse divided by 2. Let us check how much you can recall about the special triangles by doing Activity 1. In Activity 1A, fill each blank with the correct word to make the sentences correct. 1. In a 30-60-90 triangle, the length of the shorter leg is blank as long as the hypotenuse. The correct answer is half as long as the hypotenuse. 2. In a 45-45-90 triangle, the hypotenuse is blank times any of the legs. Correct answer is square root of 2 times any of the legs. 3. In a 45-45-90 triangle, the lengths of the two legs are equal. In Activity 1B, you are asked to solve 4 triangles. Solve for the unknown sides or angles of the triangles. Shown on the screen is the first triangle. Pause this video, then solve for M and N. Here is the answer for the first triangle. Check if we have the same answers. N, the shorter leg, is equal to 6, and M, the longer leg, is 6, the square root of 3. The second triangle is shown on the screen. Pause this video again, then solve for A and B. Compare your answers with mine. Angle A is 45 degrees since this is a 45-45-90 triangle. And the hypotenuse is 8 the square root of 2. The third triangle is shown on the screen. Again, pause this video, then solve for S and R. Compare your answers with mine. S, or the shorter leg, is 4 square root of 3, and the hypotenuse is 8 square root of 3. So R is 8 square root of 3. The fourth triangle is shown in the screen. It is actually composed of two special triangles. Solve first for Y and Z. Pause this video and solve. Y is 10 since this is also 10. And Z is 10 square root of 2. Now let us solve for the other side of the We're done with Y and Z. Let's solve for X and W. Pause this video, then solve for X and W. Compare your answers with mine. X, which is the shorter leg, should be 10 square root of 3 over 3. While W, which is the hypotenuse, is 20 square root of 3 over 3.
How did you find activity 1? It should be easy because we were just reviewing our past lessons. Now, are you ready for something new? Let's explore the properties of the special triangles so we can discover more about trigonometric ratios.
So what's new? Let us study isosceles right triangle DEF. Given that the leg line segment DF is 1 unit long, can you tell me what the length of line segment EF is? Yes, that's right. Line segment EF is also 1 unit long since the legs of an isosceles right triangle are equal. Now, what is the length of line segment DE, which is our hypotenuse? Wonderful! Our hypotenuse is square root of 2 units long because hypotenuse is equal to square root of 2 times any of the legs. And since the leg is equal to 1, square root of 2 times 1 is simply square root of 2. Now keep this in mind and let us study the primary trigonometric ratios of a 45-degree angle. Now, in this triangle, our hypotenuse is the side opposite our 90-degree angle, which is line segment DE. This is our hypotenuse. Now, if our reference angle is angle E, can you point me to the opposite side of angle E? Yes, you're right again. Our opposite side is line segment DF. And our adjacent side is, of course, line segment EF. Now, having identified the opposite, adjacent, and hypotenuse sides, let us now solve for the sine, cosine, and tangent ratios of a 45-degree angle. From the mnemonic SOHCAHTOA, we know that sine is opposite over hypotenuse. Ka for cosine is adjacent over hypotenuse. And TOA for tangent is opposite over adjacent. Now, let us substitute then the sides by the length of the sides in this triangle. So, opposite is 1 over the hypotenuse, square root of 2. So, we have 1 over square root of 2 for sine 45 degrees. But since we have a radicand in the denominator, we need to rationalize this by multiplying both the numerator and the denominator by square root of 2. So we have 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, which is further simplified as 2. Therefore, sine of 45 degrees is square root of 2 over 2. Next, let us solve for cosine 45 degrees. Adjacent is 1 over hypotenuse square root of 2. So we have 1 over square root of 2. Just like the sine ratio, we have a radicand in the denominator. So let us rationalize the fraction by multiplying both the numerator and the denominator by square root of 2. And to simplify, let us multiply 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, further simplified as 2. Therefore, cosine 45 degrees is square root of 2 over 2. And you notice that the sine and cosine ratios are the same in value. Now, let us proceed to the tangent ratio of a 45-degree angle. The opposite side is 1 over the adjacent side, which is also 1. So we have 1 over 1. And 1 divided by 1 is simply 1. And now, we have already solved for the 3 primary trigonometric ratios of a 45-degree angle. Let us explore the properties of a 30, 60, 90 triangle, triangle ABC, with a shorter leg of 1. If the shorter leg is 1, what do you think is the length of the hypotenuse? Correct! The hypotenuse is 2 units long because the hypotenuse in relation to the shorter leg is twice as long as the shorter leg. So 2 times the shorter leg, which is 1, 2 times 1 is simply 2. And our longer leg, can you tell me what the length of the longer leg is? Very good! Our longer leg is square root of 3 units long. Why? Because the longer leg is square root of 3 times the shorter leg, which is 1. So square root of 3 times 1 is simply square root of 3. Now keep in mind these properties or relationships of the sides of the 30, 60, 90 triangle, and let us solve for the trigonometric ratios of a 30-degree angle. Let us now solve for the primary trigonometric ratios of a 30-degree angle. Let us first identify our hypotenuse. The hypotenuse is the side opposite the right angle. Therefore, our hypotenuse is line segment AB. Now, let us encircle our reference angle, 30 degrees. Can you tell me where the opposite side is? Yes, you're right again. Our opposite side is line segment BC. And of course, the third side is our adjacent side since it lies beside our reference angle. Now, let us then solve for the primary trigonometric ratios of a 30-degree angle. Are you ready? So, let us solve first for sine of a 30-degree angle. Sine is opposite over hypotenuse, and our opposite side is 1 unit long over the hypotenuse, which is 2. So 1 over 2 is 1/2. Therefore, sine of 30 degrees is 1/2. Next, what is the value of cosine 30 degrees? Adjacent side is square root of 3 over the hypotenuse, which is 2. So we have square root of 3 over 2. This cannot be simplified further, so let's retain it as it is. Therefore, cosine 30 degrees is square root of 3 over 2. And lastly, what is the value of tangent 30 degrees? It is opposite over adjacent, so we have 1 over square root of 3. But since we have a radicand in the denominator, let us rationalize the fraction by multiplying both the numerator and the denominator by square root of 3. So we now have 1 times square root of 3 is square root of 3. And for the denominator, square root of 3 times square root of 3 is square root of 9, which is further simplified as 3. And so, tangent 30 degrees is square root of 3 over 3. We now have solved for the primary trigonometric ratios of a 30-degree angle. Lastly, let us solve for the primary trigonometric ratios of a 60-degree angle. Let us first identify our hypotenuse. So, like a while ago, our hypotenuse is line segment AB since it is the side that lies opposite our 90-degree angle. Next, let us encircle our reference angle, which is angle B or the 60-degree angle. Where do you think is the opposite side? That's correct. Our opposite side is line segment AC, which is square root of 3 units long, and the third side is our adjacent side. Now keep this in mind and let us solve for the primary trigonometric ratios of a 60-degree angle. Let us then solve for the primary trigonometric ratios of a 60-degree angle. Sine 60 degrees is opposite over hypotenuse, and the opposite side is square root of 3 units long, while the hypotenuse is 2. So we have square root of 3 over 2. Again, this cannot be simplified further. Therefore, sine 60 degrees is square root of 3 over 2. Next, cosine 60 degrees is adjacent, which is 1 over hypotenuse 2. So 1 over 2 is 1/2. Therefore, cosine 60 degrees is 1/2. And lastly, what is tangent 60 degrees? Tangent 60 degrees is opposite, which is square root of 3 over adjacent 1. We have then square root of 3 over 1, which is further simplified as simply square root of 3. And there we have just solved for the 3 primary trigonometric ratios of a 60-degree angle.
Keep in mind the properties of the special triangles and let us study more about the trigonometric ratios of the special angles.
In the previous part of this lesson, we have recalled the mnemonic SOHCAHTOA for the primary trigonometric ratios. Now let us recall the other 3 trigonometric ratios through the mnemonic CHO, SHA, COW. CHO stands for cosecant is equal to hypotenuse over opposite. As you can see, this is the reciprocal ratio of sine. Next is SHA. It stands for secant is equal to hypotenuse over adjacent. This is the reciprocal ratio of cosine. And lastly, COA stands for cotangent is equal to adjacent over opposite. This is the reciprocal ratio of tangent. Now let us proceed in finding the trigonometric ratios of the special angles, 45 degree, 30 degree, and 60 degree angles. Let us start with the 45 degree angle. Let us go back to our illustration a while ago. Triangle DEF, which is a 45, 45, 90 triangle. So the legs are 1 unit long and the hypotenuse is square root of 2 units. Now, the hypotenuse is line segment DE, and since our reference angle is angle E, then line segment DF is the opposite side, line segment EF is the adjacent side. And let us just recall that sine of 45 degrees is opposite over hypotenuse. So that is 1 over square root of 2. When rationalized, it is square root of 2 over 2. And cosine 45 degrees is adjacent over hypotenuse. That is 1 over square root of 2, rationalized as square root of 2 over 2. And lastly, tangent 45 degrees is opposite over adjacent. That's 1 over 1, which is simply 1. Now, let us find out the cosecant, secant, and cotangent ratios. So, hypotenuse over opposite is square root of 2 over 1. So, we have square root of 2 over 1 is simply square root of 2. Next, secant 45 degrees is hypotenuse over adjacent. That's square root of 2 over 1. So we have square root of 2 divided by 1 is square root of 2. Therefore, secant 45 degrees is square root of 2. And lastly, cotangent 45 degrees is adjacent over opposite. That's 1 over 1, which is simplified as 1. Therefore, cotangent 45 degrees is 1. So there we have the 6 trigonometric ratios of a 45 degree angle. Let us notice that the sine and cosine ratios are the same, the tangent and cotangent ratios are the same, and the cosecant and secant ratios are the same. So, what trigonometric ratios of a 45 degree angle have a value of square root of 2 over 2? Well done! They are sine and cosine ratios. Next, what trigonometric ratios of a 45 degree angle have a value of 1? You're right! They are tangent and cotangent. And lastly, what trigonometric ratios of a 45 degree angle have a value of square root of 2? That's correct! They are cosecant and secant ratios. So, shall we proceed to the 30 degree angles? Here we have the same triangle that we have been using in the previous part of this lesson. Triangle A, B, C. And the shorter leg is 1. The hypotenuse is 1 times 2, which is 2, and the longer leg is square root of 3. So our reference angle is this 30-degree angle here. Let us recall the primary trigonometric ratios. Sine 30 degrees is? Yes, sine 30 degrees is 1 over 2 or 1/2. Now, what is cosine 30 degrees? You're right again. It's square root of 3 over 2, which is written as square root of 3 over 2. And tangent 30 degrees is? You got it. It's opposite over adjacent. 1 over square root of 3 is 1 over square root of 3 rationalized is square root of 3 over 3. Now let us find the other 3 trigonometric ratios of a 30-degree angle. Let us start with cosecant 30 degrees. That's hypotenuse over opposite. So 2 over 1 is 2 divided by 1. It is simplified as 2. Next, secant 30 degrees is hypotenuse over adjacent. So we have 2 over square root of 3. However, since we have the radical number in the denominator, let us rationalize the fraction by multiplying both the numerator and the denominator by square root of 3. So when we simplify, we have 2 times square root of 3. The answer is 2 square root of 3. For the denominator, square root of 3 times square root of 3, that is square root of 9, further simplified as 3. And lastly, to solve for cotangent 30, it is adjacent over opposite, so square root of 3 over 1, which is simplified further as square root of 3. So there we have the 6 trigonometric ratios of a 30-degree angle. So for you to easily memorize, remember that sine and cosecant are reciprocal ratios. So we have 1/2. The reciprocal is 2 over 1 or simply 2. Next, cosine and secant are reciprocal ratios. So square root of 3 over 2, and the reciprocal is 2 over square root of 3. But when rationalized, secant 30 degrees is 2 square root of 3 over 3. And lastly, tangent and cotangent are reciprocal ratios. So we have here 1 over square root of 3. The reciprocal is square root of 3 over 1 or simply square root of 3. Okay, so let us now proceed to our last special angle. Let us now solve for the trigonometric ratios of the last special angle, the 60-degree angle. Let us use the same triangle that we have used with the 30-degree angle. So we have here as our reference angle, the 60-degree angle, which is angle B. So the opposite side is line segment AC, which is square root of 3. Adjacent side is line segment BC, which is 1. And the hypotenuse is, of course, line segment AC with a length of 2. Now, let us recall the 3 primary trigonometric ratios. Let's start with sine 60 degrees. Can you tell me what sine 60 degrees is? You're right, that is opposite over hypotenuse, square root of 3 over 2. And what is cosine 60 degrees? You're right again, that is adjacent over hypotenuse, 1 over 2, which is 1/2. And lastly, what is tangent 60 degrees? Excellent! That is opposite over adjacent, which is square root of 3 over 1, further simplified as square root of 3. So now that we have the primary trigonometric ratios, let us solve for the other reciprocal ratios. Let's start with cosecant 60 degrees. Cosecant 60 degrees is hypotenuse over opposite, that is 2 over square root of 3. But since there is a radical number in the denominator, let us rationalize the fraction by multiplying both the numerator and the denominator by square root of 3. And when we multiply, 2 by square root of 3 is 2 square root of 3. Square root of 3 times square root of 3 is square root of 9, further simplified as 3. So cosecant 60 degrees is 2 square root of 3 over 3. Next, what is secant 60 degrees? It is hypotenuse over adjacent. So we have 2 over 1. And 2 over 1 is 2 divided by 1, simply 2. So secant 60 degrees is 2. And last, what is cotangent 60 degrees? It is adjacent over opposite. So we have 1 over square root of 3. That's 1 over square root of 3. But since there is a radical number in the denominator, let us rationalize the fraction by multiplying both the numerator and the denominator by square root of 3. So when we multiply the numerators, 1 times square root of 3, we have square root of 3. And the denominators, square root of 3 times square root of 3 is square root of 9, or simply 3. Therefore, cotangent 60 degrees is square root of 3 over 3. So there we have the 6 trigonometric ratios of a 60-degree angle. Let us summarize the primary trigonometric ratios of a 30-degree, a 45-degree, and a 60-degree angle. Recall that sine 30 is 1/2, cosine 30 is square root of 3 over 2, and tangent 30 is square root of 3 over 3. Now, when you study the other ratios, can you notice a pattern? How observant you are! Yes, all the sine ratios have a denominator of 2, while the numerators are arranged such that for the sine ratio of a 30-degree angle, the numerator is 1, and for 45 degrees, it is 2, but it is a radical number. And for 60 degrees, it is square root of 3. So we have 1, 2, 3. However, 2 and 3 are radical numbers. And for the cosine ratios, it is the other way around. It is decreasing. So we have square root of 3, then square root of 2, then 1. So there we have the patterns if you want to memorize the trigonometric ratios of special angles. Let's apply what we have been learning. Let's start with number 1. Evaluate sine 45 degrees plus cosine 60 degrees. So since we know that sine 45 degrees is square root of 2 over 2 and cosine 60 degrees is 1/2, we have sine 45 degrees is square root of 2 over 2. So we just substituted sine 45 degrees by its value, and cosine 60 degrees is substituted by 1/2. So if we add, remember that when adding similar fractions, since their denominators are the same, just add the numerators and copy the common denominator. So we have square root of 2 plus 1 cannot be simplified further, and then copy the common denominator, which is 2. So the value of sine 45 degrees plus cosine 60 degrees is square root of 2 plus 1 all over 2. So you may pause this video if you want to study this example further. Second application. Evaluate cotangent 60 degrees times secant 60 degrees over 2. Since cotangent 60 degrees is square root of 3 over 3, and secant 30 degrees is equal to 2 times square root of 3 over 3, let us substitute cotangent 60 degrees by the value, which is square root of 3 over 3. This is the value. So next, secant 60 degrees is this one, so let us substitute the value by 2 square root of 3 over 3. So they are multiplied together. Since cotangent 60 degrees and secant 60 degrees are placed beside each other. And then copy the denominator 2. Now to simplify this, let us multiply the numerators. So we have square root of 3 times square root of 3 is square root of 9. And then the 2 here is placed there. Next, 3 times 3 is 9. I already simplified the division symbol here. Remember that when dividing fractions, instead of dividing, you can multiply the fraction by the reciprocal of the divisor. So the reciprocal of 2 is 1/2. So I multiplied 2 square root of 9 over 9 by 1/2. Now, to simplify further, we have here a common number in the numerator and the denominator. Let's cancel that out. So we have 2 divided by 2 is 1. And then, square root of 9 is 3. Square root of 9 times 1 is 3. And 9 times 1 is simply 9. Now to simplify 3 over 9, when we divide 3 by 3 and 9 by 3, 3 divided by 3 is 1, 9 divided by 3 is 3. Therefore, cotangent 60 degrees times secant 60 degrees over 2 is 1/3. If you want to study this example further, you may pause this video or replay this part. Third application. Find the exact value of 4 times cotangent 45 degrees squared minus secant 60 degrees squared plus sine 60 degrees squared plus cosine 60 degrees squared. So we know that cotangent 45 is 1. Secant 60 degrees is 2, sine 60 degrees is square root of 3 over 2, and cosine 60 degrees is 1/2. Let us then substitute the values of the trigonometric ratios. So the 4 here, I just copied it here below. Now, cotangent 45 degrees is 1, so that is 1 squared because cotangent squared is the given. Next, minus. We know that secant 60 degrees is 2. So we have here 2 raised to 2, since second squared. We have second squared here. Next, plus sine 60 degrees squared. So we have square root of 3 over 2, the quantity raised to 2. And lastly, cosine 60 degrees squared. We have here 1/2 as the value of cosine 60. So we have here the quantity 1/2 squared. And now let us simplify. 1 raised to 2 is 1 times 1, which is simply 1. 1 times 4, 4. Next, 2 raised to 2 is 2 times 2, which is 4. So we have here 4. Next, square root of 3 times square root of 3 is simply 3. And 2 times 2 is 4. Last, 1 raised to 2 is 1 times 1, 1. And then 2 raised to 2 is 2 times 2, that's 4. Now to further simplify, we have 4 minus 4 is 0. And if we add 3/4 and 1/4, when we add the numerators, 3 plus 1, that's 4. And then copy the common denominator, which is 4, that's 4 over 4, or simply 1. Therefore, the value of this very long trigonometric expression is simply 1. If you want to study this further, you may replay this video, or you may pause and study the example on your own.
Are you ready for more exercises? Let us apply what we have just learned to solve expressions involving trigonometric ratios of special angles.
Simplify each trigonometric expression in activity 3. Pause this video, then continue answering. Let us check your answer by comparing it with the answers shown on your screen.
Sum up what we have just learned by filling up the table of trigonometric ratios of special angles on page 9.
Fill up the table of trigonometric ratios of special angles. Pause this video, then fill it up. Now let us check your answer by comparing it with the answers shown on your screen. You may pause this video while checking.
You might have been wondering, where can I apply these concepts in real life? Let us solve the following real-life problems using the concepts we have just learned.
Let us do activity 4, problem solving. First problem, Jane goes to school each day by walking 200 meters due north, and then turning right and walking another 200 meters due east. If she had walked in a straight line, what would be the angle between her home and the school if the beginning of the angle is taken from due north? You are given 3 seconds to do this. And the answer is 45 degrees. Since we have here an isosceles right triangle. Second problem. When on a camping trip with your friends, you take an orienteering trip. You end up on a course which results in you hiking 30 degrees west of due south. You hike until you are 150 meters from where you started. How far south are you from where you started? You are given 3 seconds to do this. And the answer is 75, the square root of 3 meters.
Check how much you have learned by answering the post-assessment. Read and understand the questions and choose the correct answer. Then write the letter that corresponds to the answer on your answer sheet. You will be given 3 seconds to answer each item.
First question. Which of the following statements is incorrect about trigonometric ratios? A. The ratio of sine theta is opposite side divided by the length of the hypotenuse. B. The ratio of cosine theta is adjacent side divided by the length of the hypotenuse. C. The ratio of tangent theta is opposite side divided by the length of the hypotenuse. Or D. The ratio of cosecant theta is the length of the hypotenuse divided by the opposite. Second question. Given a 45-45-90 triangle with hypotenuse of 10 centimeters, what is the length of each leg? A. 5 centimeters. B. 10 square root of 2 centimeters. C. 5 square root of 2 centimeters. Or D. 5 square root of 2 over 2 centimeters. Third question. The length of the hypotenuse of a 30-60-90 triangle is 12 centimeters. What is the length of the side opposite the 60-degree angle? A. 6 centimeters. B. 12 square root of 3 centimeters. C. 6 square root of 3 centimeters. Or D. 24 centimeters. Pause this video and continue answering items 4 to 10. Let us check your answers by comparing it with this answer key. 1. C. 2. C. 3. C. 4. B. 5. D. 6. D. 7. B. 8. A. 9C, and 10A.
What was your score in the post-assessment? If your score is 0 to 4, study the lesson again. If it is 5 to 7, review the items you did not get right. And if it is 8 to 10, congratulate yourself for a job well done.
For part A of additional activities, solve for the angle theta. Pause this video, then answer. Let us now check your answers. Check them if they are the same with the one shown on your screen. For additional activities B, fill in the blanks with the correct value to make each trigonometric equation correct. Pause this video, then continue answering. Now let us check your answers. Check your answers if they are the same with the one shown on your screen.
To further enhance your mastery of the lesson, answer the additional activities. Good job, math learners, for making it this far. See you in the next lesson. This video lesson was based on the self-learning module developed by Maricel D. Ambacod of DepEd's Coast Division of Baguio City.